In today's video, we're talking about roofing ventilation, categories, products, and options for venting. What's up, guys? Welcome to the Metal Roofing channel. I'm Thad Barnette. Make sure you subscribe if you're new. We release metal roofing and metal construction content every Monday and Wednesday. Today, we're talking about ventilation. We're going to discuss what it is, why it's important, some different options depending on your building type or your house design, and some product options out there. And today, to help me out, I have Jeff Hock from Sheffield Metals. Jeff, thanks for being here today. So let's start with, what is ventilation? Let's start there, discuss kind of why that's important for me.
So ventilation is going to be moving air throughout your building or your roof system. The idea is that colder air is going to come in from lower spaces, and it's going to drive that hot air out through either the peak of your roof or something similar. The reason it's important is it can dramatically reduce the heat that gets into the building or structure that you're living or occupied in. Another benefit, is that it can help create cooler roofs, which in winter times might help with ice damming and things like that.
So let's talk about some of the main categories of venting, depending on your building design, whether you have an attic, whether it's a conditioned attic, unconditioned. Talk to me about some major categories.
Yeah, so I think the first major one is going to be, a vented attic situation. That's probably going to be the most common, especially residential. Most people do have an attic space. Most of the time you do have a soffit on the outside of your overhangs. So that's going to be probably what you see most typically in a residential application. The idea behind that is that you either have a vented soffit. So when you go outside, you look up at your overhang and you see this panel with a bunch of holes in it. That's actually allowing cooler air from lower on the ground to get into your attic space, and then it's vented up through a ridge vent, or if you don't have a vented ridge, you might have like those whirlybirds, spinning turbines on your roof, things like that. And again, the idea is for the cooler air to come in lower and to drive the hotter air up and out of your attic space to hopefully reduce the amount of heat that's susceptible to inside your building.
So you mentioned things like ridge venting and turbines, those whirlybirds. Talk to me a little bit more about vented attics and things to remember.
I think both of the products accomplish the same goal. I think one thing to keep in mind when you're looking at which product to use or what might be more applicable to your building design is you want to keep in mind how much you actually need to vent. Because if you're over venting, you're going to lose some of the properties that you're trying to maintain from venting. And if you're not venting enough, then obviously, you're not getting as much out of this vented system as you could. You want to make sure that they know what they're talking about when it comes to vented, and there should be an amount that you have to vent per the size of your attic or the space that you're trying to vent. And that will determine how much either ridge of your ridge that you need to vent, or how many of those turbine or whirlybird systems you need to have installed. So that's one of the things to keep in mind when it comes to an attic situation. The other thing to keep in mind too is, whether or not it's a enclosed attic. If you have a conditioned attic, then obviously you're not going to be venting that space, because you're going to be venting all that air conditioned or cooled air right out of your system. And that's obviously counterproductive. So depending on what type of insulation and what type of attic you have will really determine your venting needs and what's going to be proper for your building design.
So if you have a conditioned attic where it's sealed, it's a sealed environment, it's part of the building envelope, what are your options for venting there, or do you even need venting?
So you're not going to need venting inside the attic space, because again, we're talking about a conditioned area. You do have options as far as venting still the roof system. And that's the next thing that we're going to talk about, is the above sheathing ventilation options, and actually venting your roof deck instead of going through the attic space. And that could be, the case whether it's a conditioned attic or if you just don't have an attic condition at all. So you have high cathedral ceilings, things like that. You don't have a space to vent. Then we're going to move into more of a above sheathing ventilation type situation.
So why is it important to use some kind of above sheathing ventilation if you don't have an attic? Is it the same principles that still apply?
So the above sheathing ventilation, there's been a lot of studies and things done lately, especially with metal roofing involved. And the idea of creating an air gap is, again, to stop that heat transfer from getting into the building. So if I have a metal roof that gets very hot and it's directly on a deck, that heat can transfer from the metal roof to the decking and potentially get inside your building. If you have vented space between your metal panels and your decking, and you can move that hot air away so it isn't absorbed into the building itself, then you might be able to reduce energy costs and things like that. You're moving that heat source away from directly getting into the building.
So let's talk a little bit about some different requirements, because we've talked about moving hot air away from the roofing system. But what about like a colder climate? Does venting help in that area as well?
Yeah, so one of the things venting can do is create basically a cold roof, where the idea is instead of the heat from inside your house coming up and heating your roof system, which could cause ice damming. Basically, you have a bunch of snow on your roof. The heat from inside your building thaws it out just a little bit. It gets colder. Next thing you know, you create an ice blocks on top of your roof. If you have a venting scenario, you can take and basically create a roof that's the same temperature as the outside ambient air. So therefore, you're not going to have that thaw freeze process going on your roof, and you should hopefully not have ice damming conditions, which can cause damage depending on how severe the climate is that you're in.
What about specific products when it comes to above sheathing ventilation? How do you accomplish that?
So you got a bunch of different options out there. I think the most widely used one and known, been used forever, is probably 1x4s. They'll put 1x4s down on top of your decking or your existing roof structure, and then they will attach the roof to that. 1x4 is 3/4 of an inch thick, which is, from my understanding, the minimum necessary gap that you need to be considered above sheathing ventilation. You need a minimum 3/4 air gap to have that air be able to move properly to get in and out. So that's one. Other products you have are Incomat, which is basically like a plastic mesh that goes down. You install your roof directly on top of that. It creates an air gap underneath the metal panels themselves. It's compressible. You have products like the Dimple Mat. It's more rigid. Things that you want to consider when looking at both those products is the thickness of them. If 3/4 inch is the magic number that you want to hit, I don't believe either one of those products come out to 3/4 of an inch. But again, based on who you're talking to with your ventilation needs and things like that, the calculations might come out fine based on the amount of air it moves. Another product out there is from Hunter Panels. It's called Cool Vent. This is more if you're going for a insulation on top of your roof situation, but long story short of it is a layer of rigid ISO with a adhered piece of plywood or OSB with the 3/4 inch air gap already built into it. You get a solid surface. You do get at least a minimum 1 inch ISO, so you're getting some R value there as well. And then you have the venting is actually above the sheathing of the building, but it's below the sheathing of the panels. So the panels still have a direct surface to contact, just like you would a normal plywood installation, only the venting is actually going to go on in between that layer of ISO and in between that layer of plywood that the panels are installed on.
So all those products that you mentioned still have to have some sort of air intake at the eave, right? And then some sort of exhaust at the ridge.
Correct. So pretty much every product we talked about is going to have a vented ridge cap. Okay, so you're going to have some way to have that air escape between the decking itself and the top of the panels. So you're going to have a vented ridge cap pretty much in every one of those scenarios. Now, how you vent the eave is going to be a different story. Obviously, you don't have a soffit, so you're going to have to vent the eave itself. Products that we use for both venting the ridge and venting the soffit is made by a company called Cora Vent. They make ridge venting solutions. They make eave venting solutions. I mean, their whole company is about venting, and they have different products, are applicable for each situation.
All right, so this is good information about above sheathing ventilation. Let's talk about some pros and cons with some of the different systems that you mentioned.
Okay, so, starting off with the 1x4s, probably the biggest con is it could very well affect your engineering. That's the biggest one. If you're going for an engineered system and, my engineered system is over plywood, well, that is not the same as spanning 1x4s at 2 foot on center. unless you have an engineer do calculations for you, you very well could be coming into problems when it comes to meeting engineered system requirements with a substrate that hasn't been tested over. And probably the second biggest one I see happening when it comes to using 1x4s for venting, people take and they just put them horizontally on the roof. So you're going from rake to rake. So if I have him going rake to rake, that is pretty much stopping that airflow from eave to ridge, because you're stopping a lot of that flow of air by those 1x4s going horizontally up the roof. You'll see in a couple of videos that we've done in the past where the 1x4s are pointed diagonally. Now that is a way to combat that, because the diagonal system will eventually let the air get from the eave to the ridge. Another way to do it is basically you do a checkerboard. You have your 1x4s running vertically up the roof, and then you come back and you put another set of 1x4s horizontally, basically making a grid. And that again will allow the airflow. But there's difference between an air gap and an airflow. You can have a 3/4 inch air gap, but if that air isn't able to move from eave to ridge, then you don't have the airflow needed, even though you might have the gap required. That's probably my 2 cents on the 1x4s. For the Inca mat products and the dimple mat products, again, like we talked about, I think the one thing you need to look into there is the thickness of it and making sure that the gap is going to be sufficient enough to be able to provide enough venting for for what it is you're trying to do. It very well could be. But again, you won't know until you talk to a venting specialist and have calculations done to figure out how much air you need to move or should be moving.
And I think with those products, if you have your system already vented with something else, your attic is vented maybe, a product like that could provide like another thermal break between your metal and your decking. So even though it doesn't have to provide that full airflow to have true ASV, it still provides some sort of thermal break and give you some R value there.
Great point. And we noticed that too in the videos that we tested with the different roof panels, that even any type of thermal break seemed to make a pretty good difference when it came to temperature wise. So the last one, the cool vent, that's probably the Cadillac of all the different options to go with. But it's obviously going to be the most expensive. Rigid ISO isn't cheap. Obviously you're getting your decking out of it, so you might have technically 2 decks on your building. So it's definitely going to be the most expensive option. But at the same time, you are going to get more R value because of the insulation, and you are going to have a solid surface to attach, all of your panels and trim to and everything like that. So there's definitely a lot of benefits that come with it, but the price tag is obviously, it's downside, if you want to call it a downside.
Another thing about the Hunter panels is that because you're attaching your roof system to a solid deck now with plywood or OSB, then you can meet those engineering requirements. Is that right?
Absolutely. You're going to want to make sure that the OSB is going to be thick enough. 7/16 OSB isn't going to cut it for most people's engineering. But yes, no, you're absolutely right. Engineering concerns kind of are taken away because you do have that solid deck that was tested over.
And you mentioned the core vent products a little bit before about the eave and the ridge details. Talk to us about that.
I guess when it comes down to venting products in general, core vent, you're talking about the whirlybirds or the turbines and whatnot. We've kind of mentioned a couple of times in the video so far, depending on how much venting your roof needs or your attic needs. Well, these products give you how much airflow that they move per cubic foot. So that's something good to know when you're trying to figure out, do I need to vent my whole ridge? Do I need to vent part of my ridge? We're talking earlier about, having too much ventilation or not enough. You're not going to be able to know that unless you have the calculations done, and then the products that you're using, how much air they're able to move. It takes a lot of the guesswork out of it than say, oh, well, I'm just going to add another turbine here just to be safe. Or I'm just going to vent the whole ridge and, I don't know the numbers on how much air I'm moving. I'm just going to vent the whole ridge and call it good. Using the products that are made for venting, you'll get that information to be able to use to determine how much of it you need to be using to make sure that your space is properly ventilated and not over ventilated or under ventilated.
Yeah, that's a great point. And not only that, there's a specific ratio that you should have when it comes to your soffit vents versus your ridge vent. If you have too much ridge venting or you have too much exhaust, then that air could actually come and move the opposite direction that you want it to. So there's considerations there as well.
Correct. Yeah, it's not. It's there's calculations for everything, and there's specialists out there for every situation. I've seen houses before where just some of the soffits are vented, not all of them, for the exact situation you're talking about. I've seen roofs where 30 feet of the ridge is vented, and that's it on the whole project. It just depends on the products you're using, how much air needs to be moved, and how much air those products allow to move.
Yeah, and I think that's an important point about all of this is it really depends on your project. The goal might be the same with moisture control, temperature control, energy considerations, but the way it's actually accomplished really depends on the project. All right, thanks, Jeff. Really appreciate the information. And if you want to learn more about ventilation, conditioned versus unconditioned attic spaces, subscribe here to the Metal Roofing channel. We've done some videos in the past with Matt Reisinger and a couple other people like Todd Miller as well. You check those videos out. I'll put links in the description down below. Comment if you have any questions. And as always, I'm Thad Barnette, and we'll catch you next time.